Here is a problem on the mean value theorem. Verify the function satisfies three hypotheses. Hypothesis means conditions. What are the conditions of mean value theorem? We also call it MVT. Number one, f is continuous on the closed interval. The second one, f is differentiable on the open interval. Okay, there are two conditions of mean value theorem. Let's look at the function. The function is a polynomial function. Polynomial f of x is polynomial. Polynomials are continuous everywhere. So this condition is automatically satisfied. And also polynomials are differentiable everywhere. So this condition is also automatically satisfied. Once we verify the conditions, this part is done. We need to write the conclusion of the mean value theorem. What is the conclusion? Then there exists a C in the interval. Which interval we are talking about? 0 to, such that f of b minus f of a divided by b minus a is equal to f prime c. In this case, a is equal to 0, b is equal to 2 because the interval is 0, 2. That means we are asking f of 2 minus f of 0 by 2 minus 0 is equal to f prime at c. We need to find the c. The question is find all number c such that satisfies the mean value theorem. Okay, let's figure this out first on the side. What is f of 2? F of 2 can be 2 times 2 square minus 3 times 2 plus 1. This is 8 minus 6 plus 1, which will be 3. F of 0 would be 2 times 0 square minus 3 times 0 plus 1, basically 1. And also, what is the derivative of x? F function. That's 4x minus 3. Let's use all these three here to fill in our conclusion. F of 2 is 3 minus f of 0 is 1 divided by 2 minus 0 is 2 is equal to f prime c, which is 4c minus 3. 3 minus 1 is 2 by 2 is equal to 4c minus 3. So 2 by 2 is basically 1. So we are saying 4c minus 3 equal to 1. Adding 3 on both sides, 4c is equal to 4. That implies c is equal to 1. So we found c and we can check that it clearly belongs to, it is in the interval 0 to 2. So this is the value final answer of your question. C is equal to 1, which satisfies the conclusion of mean value theorem. Here is another part of that. This is f of x is equal to 1 by x. We need to check first the conditions, continuity. I'm going to show the graph of 1 by x looks like this. On the, we are only concerned from 1 to 3. So 1 is here, at 1 the value is 1, and 3 it'll be 1/3. So only part of the graph I am concerned is this, right? Although it looks like it's not continuous at 0, I do not care about that, right? From 1 to 3, function looks pretty continuous. So f is continuous in the closed interval 1 to 3. Also, f is differentiable in the open interval 1 to 3 because there is no corner or break or kink, right? So the function is pretty differentiable. Both the MVT, mean value theorem, conditions are checked. So we can write the conclusion. Conclusion is, if you remember, there is a C, there should be a C belonging to the interval such that f of b minus f of a divided by b minus a is equal to f prime of c. Okay, let's find all these things on the side. F of B is 3 here, so f of 3 minus f of 1 divided by 3 minus 1 equal to f prime of C. What is f of 3? That should be just 1 by 3. F of 1, that should be just 1 by 1 equal to 1. And what is f prime of x? Function is 1 by x. The derivative of that is negative 1 by x square. So let's write all that down here. F of 3 is 1/3 minus 1 divided by 2 is equal to f prime of c, negative 1 by c square. 1/3 minus 1 is negative 2/3 divided by 2 equal to negative 1 by c square. 2 can cancel here, so we have negative 1/3 equal to negative 1 by c square. This negative can also cancel, so we have 1 by c square equal to 1 by 3. C square equal to 3. C would be equal to plus minus root 3. Now, we are getting plus minus, but we can't take, that means it is basically root 3 and negative root 3. We cannot take negative root 3 because our interval is only from 1 to 3. So what is your answer? Our answer is C is equal to root 3 because that does belong to the interval 1 to 3. This is your final answer to find all the number C which satisfies the conclusion of the mean value theorem.